and download the class RMD file from Canvas, and then run this chunk of code. There are 4 chunks, okay, and I have a blue equal to sign, line of equal to signs. Okay, so that's the code that you have to run before we can proceed. Okay, so read the data into the data frame, change fireplace to factor, change the name of total dot value, and run the partitions. So we will have 2 partitions, train and valid. Okay. So, and these 4 chunks of code will take us to where we left off on Thursday. So now we have all the data frames ready for us to use. Okay. So the last topic in this chapter is to build a predictive model, because we're going to use regression analysis. Right now, we don't need to, we're not going to go into regression analysis. In chapter 6, we're going to do a whole chapter on regression analysis. So now, all we are trying to do is to come up with some prediction, okay, and then build accuracy measures. So here are the steps that we go through in model building, okay. So, and we are assuming that all of these first few steps have already been done. So we now know our objective is to look at the West Roxbury data and then come up with a model to predict value of homes. And we have the data from West Roxbury, and we did some exploring and analysis and summary statistics and all that. And we will do more of that in chapter 4. But for now, we'll assume that we have checked for outliers, we checked for missing values. We went over how to do all that already, right? So we have done all that, okay? And now we have determined that we're going to predict the value of total, the column named total value, so using a regression analysis, okay? Now in the regression analysis, we look at the variables that are in the data set, and here one thing we need to note is tax is also part of this data set, okay? Okay, there are a couple of things that we need to realize. One is the remodel is a non-numeric column, okay? It is a factor. There are 3 possible values, none, recent, and old, okay? At fireplace, 0 or 1, we coded that as a factor. So those 2 are non-numeric columns. Okay, we have to keep that in mind. And one more thing that we need to realize is tax cannot be a predictor because tax is derived from the total value. So once the total value is assessed, a certain percentage of that becomes tax. So tax comes after total value, not before. And therefore, tax cannot be a predictor. So we cannot use tax in our model. Okay? So with that background, okay, let's go ahead and run the model. Okay? So what we're going to do is we have the train partition, and then we have the valid partition, the validate set. So we're going to use the train set to develop the model. Okay? And then once the model is developed, we will use that model with the validate data set and measure the accuracies. Okay? So that's what we're going to do here. So the regression analysis that we want to run, okay, so here, all right. So LM is the code. LM stands for linear model. Okay, so linear model, and we can use this for many different linear models, but we're going to use it for regression analysis. So the first parameter that we have to specify is the model formula. So you see that there is formula and then the data. And then there are lots of other things. We don't have to worry about the other things. So formula here is what is the model formula that we want to fit. So which is specified with the target variable first, okay, and there has to be only one target variable. We can't have more than one target variable. And then tilde, and then what are the predictors we want to use, right, to build the model. So that is the syntax. So here we want to use total value, okay, as the target. Okay. And then we have a tilde. Okay. Now we specify the model. Okay. Now the intercept in a regression analysis is default. You don't have to say that we want intercept. If you don't want intercept, then you have to put a 0. Okay. But regression model will always have an intercept, like b sub 0 plus b sub 1 x sub 1 plus b sub 2 x sub 2 and so on. So by default, intercept will be included, so we don't have to specify that. Now if you want to include all the variables, okay, all you have to do is to put a period. Okay. But if you want only selected variables, then you have to type the variable name and then separate the variable names with plus sign. So for example, you want to use say what are the variable names? Here, okay, I have the variable name somewhere up here. Okay, so we have floors. Okay, suppose we want to use only floors and kitchen. Okay, then you type floors plus kitchen. Okay, or if you want to add one more variable, you can do that. Okay, on the other hand, suppose if you want to include everything except 1 or 2. In that case, instead of building all of these variables plus this, plus that, plus that, plus that in a huge big formula, what you can do is to say everything, everything means period, right? Everything except, so except will be specified with a minus sign. So if it is, for us, we want to exclude only tax. So we're going to say minus tax. But if you have a couple of variables you want to include 2 or 3, then you put C, okay, minus C, and then within parentheses indicate the variables you want to exclude. Okay. Here we're going to exclude only tax. We are not going to exclude the 2 factors. Remember, there is fireplace is a factor and remodel is a factor. But we don't have to exclude that because linear model, LM, the LM code, will automatically generate the dummy variables for the correct number of dummy variables. Remember, if there are k categories, we need only k minus 1 dummy variables. So LM will automatically generate the required number of dummy variables for each factor predictor, okay, as we will see. So we will exclude only tax, all right, and then you don't have to say data equal to, okay, that is understood, but let's say data equal to, and give the data name, which is housing dot df. Okay. Now what this code will do is it will run the linear model function, generate all the output that it generates, and then that's it. It won't do anything. So what we need to do is to say capture the output into a variable. Now this will be a list, an R data structure list that we did earlier. A list is one where you can have all kinds of different elements. You can have integers, you can have another list inside a list, we can have vectors, you can have matrix, you can have data frame. So that is the kind of data class of data structure that this will generate. All right, so let's go ahead and run this. Okay, so now you see reg.res, okay, has been created, and there are 13 elements in that list. So if you click this button, you'll see all the different elements there. Okay. Well, we're not going to look at that. Instead, what we will do is we will use the results. Okay, so if you now let's look at here. Let's not capture anything. Reg.res. Okay, and then if you put a $sign, so it's going to tell you what are the different items you can look at. So the first item is coefficients. You select that, then it will tell you what the coefficients are. Okay, you don't have to save this anywhere. We've already saved it. So you just want to look at it. So you say coefficients, and then you come down here, and then you see fireplace. So we have 5 different values for fireplace, 0, 1, 2, 3, 4, and you see after kitchen, of the 5 values for fireplace, there are 4 dummy variables here, fireplace 1, 2, 3, and 4. And similarly for remodel, there are 3 possible values, right? And then we have 2 dummy variables automatically created and included in the model. Okay. All right. So, and then you can look at other things too. So here we have the effects, the residuals, fitting values, and all of that stuff. Okay. So if you do model, it will tell you the model data there. Okay. All right. So now that we have the results that we have fitted, how can we use that result? Okay. How are we going to use it?